So the next thing we are looking at is nuclear fusion. Nuclear fusion. Nuclear fusion simply means a process. It is a process where two lighter nuclei, you could say nuclei or you could say atoms. It is a process where two lighter atoms combine to form a heavy atom with the release of energy. In brief, you get two lighter atoms, join them together to form a heavy atom. Now, when that heavy atom is produced, there is also energy which is released. Now, that process is what we call nuclear fusion, a process where two light atoms combine to form a heavy atom with the release of energy. Now, we can put that in the form of an equation to make us understand better that when you are dealing with the nuclear fusion, you need two light atoms. Those atoms must combine. So combining here in our equation means you add. You get two light atoms. Now, when we look at the equation, you realize that from our knowledge of chemistry, H is a chemical symbol which represents hydrogen. So when you look at this and this, they are the same. So this is a hydrogen atom, this is also a hydrogen atom. Now hydrogen, sometime back we talked about isotopes. And we said isotopes are atoms of the same element with the same atomic number but different mass numbers. Hydrogen has three isotopes. There is one where you write here 3. This one remains 1. 3, then 1. That one we call it tritium. Then there is one, this particular one, where you have 2 up and then 1 down. This one we call it deuterium. Then there's another one where you have here 1, 1. That one we call it positronium. So those are the 3 isotopes of hydrogen. The atomic numbers are, they remain 1. But the mass numbers keep on changing. This one can keep on changing. It can be 1, that is positronium. It can be 2, that is deuterium. It can be 3, that is tritium. So here we are dealing with the deuterium atoms. They are atoms of hydrogen. This is deuterium atom, this is also deuterium atom. We are combining them, we are adding them up. They are light atoms. We shall know why we are calling them light atoms. So when you join this deuterium atom together with this one, you end up with a helium atom. You see, this one is He. This is H, this one is He. He is also a chemical symbol which represents helium. If it is H, it is hydrogen. If it is He, it is helium. Now, this helium atom has atomic number 2 and mass number 3. So the helium which is produced, the helium atom, there is also one which has here 4 and this one is 2. That one is an alpha particle. But this one is 3 and 2. The mass number is 3, the atomic number is 2. So this is the helium atom which is produced. This is one of the products. Another product on top of this helium atom is a neutron. A neutron atomic number is 0, the mass number is 1. Remember in our definition we said with release of energy. You see? Which means one of the products here must be what? Energy. So why do we say these are light atoms? I want us to look at the mass number. When you're talking about light, heavy, look at the mass number. Don't look at the atomic number. Now let's look at the mass number. The mass numbers are these ones up. These ones. You realize this is 2. This one has a mass number 2. While the product which is produced has a mass number 3. So this one is heavier. Similarly, this one has a mass number 2. This one also has a 3. 3 and 2, of course, 3 is bigger. So this one has a bigger mass than this one. For that reason, this is heavier. So you have two light atoms combining to form a heavier atom. And a heavier atom is produced together with what? Energy. So this is an equation which represents nuclear fusion. So nuclear fusion, once again, is a process where two light atoms combine. Combining means what? To add up. They join to form a heavy atom with the release of energy. And the equation is right here. Two deuterium atoms joining up to form a heavy atom, which is a helium atom, but with the release of what? Energy. Why are we not talking about this? Because this one, when you look at the mass number, this one, the mass number is 1, this one, the mass number. This is even, the mass is smaller than this, which means this is lighter. Our definition says to form a heavy atom. Now, we are just including this here because it is a part of the products. A neutron is a part of the products, but the real element which is produced, which is heavier, is the helium atom, as you can compare the mass numbers. So that is an equation which represents nuclear fusion. So what does that mean? It means whenever nuclear fusion takes place, energy is what? Released. Okay. So that one now takes us to the next level. Conditions for nuclear fusion to take place. When you go back to the equation here, you'll realize that for nuclear fusion to take place, there should be two light atoms, this one and this one. So that is one condition. If you don't have two light atoms, then nuclear fusion cannot take place. So we need, that's why we are saying presence of two light atoms. There should be two light atoms. Number two, you need high temperatures. To join them, to make this one combine with this, you need high temperatures, And of course, out of the high temperatures, we also have energy being produced. So these are the two conditions for nuclear fusion to take place. There should be two light atoms, and then you need high temperatures. Now, where does nuclear fusion occur? Now, where does nuclear fusion occur? And we are saying nuclear fusion occurs in the sun. You see? It is believed that energy, that vast energy from the sun, is a result of what? Nuclear fusion. So it is as simple as saying nuclear fusion occurs in the sun. You see? Now, there is another term which is related to nuclear fusion. It also starts the word nuclear. But this is fission. I want you to note the difference. This is Fi, while this one is what? Fu. So in this case, what do we mean by nuclear fission? If you know the definition of nuclear fusion, then nuclear fission is opposite. We said nuclear fusion is a process where two light atoms combine to form a heavy nucleus or a heavy atom with the release of energy. What about nuclear fission? Now, nuclear fission here means it is also a process, but here you are having a heavy unstable atom. So it is a process where a heavy unstable atom splits, and after splitting, it forms light atoms with the release of energy. So it is a process where a heavy unstable atom splits to form light atoms with the release of energy. So, whereas in nuclear fusion, two light atoms join up to form a heavy atom, the heavy atom can again split to form light atoms. So this one is a reverse of the other one. So this one is a process where a heavy unstable. Why does that atom split? Because it is unstable. Because it is unstable, it ends up splitting, and after splitting, it forms light atoms. And in the same way, when these light atoms are produced, energy is also released. That's why we say with the release of energy. Let's have an equation which represents nuclear fission. Now, where does nuclear fission first of all take place? Nuclear fission, from the definition, it takes place in unstable atoms. because it is the unstable atom which splits. So it takes place in unstable atoms. An example of such atoms which are unstable here is uranium. In the periodic table, uranium is number 92. So uranium, we use a symbol U. So this is the equation. When you see U, it means it's a chemical symbol representing what? Uranium. The 92 here is the atomic number. Then the 235 is the mass number. Now uranium also has many isotopes. You know, the atomic number does not change, but the mass number can keep on changing. There is one we call uranium-235, which is this one. There is another one, we call it uranium-238. This part becomes 2, 3, and 8. There is another one, we call it uranium-236. All those are isotopes of uranium. Now, here we are saying an example of the one which splits is uranium-235. For it to split, you need a neutron. And remember, I said this is how we represent a neutron. You use a smaller n. Then up you write 1. What does that mean? The mass number. The mass number of a neutron is 1. The atomic number is what? 0. So when this neutron hits a uranium atom, that's why we are adding. They come together. What happens? The uranium atom, because it is unstable, it splits. And when it splits, it does not remain uranium. The products now change. You can see a neutron combines with the uranium atom, and you end up with what? Barium. Ba represents what? Barium. The atomic number of barium is 56. The atomic number is 56, sorry, and the mass number is 138. Ba is a chemical symbol in chemistry. It represents barium. Now, apart from barium, we also have krypton, which is Kr. Krypton is Kr, atomic number is 36, mass number is 95. But these two, we call them fission fragments, because these are the main products of fission. When uranium splits, you end up with the barium and krypton as the fragments. So we call them fission what? Fragments. So if somebody asks you, name the fission fragments when uranium splits, our answers would be barium, and the next one would be krypton. But these are not the only products which are what? Formed. We also have more neutrons being produced. You see, we said 1, 0, n represents a neutron. So when I put a 3 in front, it means 3 neutrons are what? Produced. Then we also have energy. You see the way we define fusion, we said with the release of energy. So energy is one of the products. So there are how many things here? There are about 4. You have barium, you have krypton, you have more neutrons, 3 of them, and what? And there is also energy. So this is our complete equation. But now, how do we balance this equation? Balancing equation means we are going to look at the mass numbers and then atomic numbers. When you add 92 plus 0, you get 92 on this side, which means when we add all these ones also this side, they should also give us 92. Let's try to add. When you add 56 plus 36, you get 92. You see? When you add 56 plus 36, you get 92. Now, this 3 here, this 3 means 3 neutrons. So when you multiply, 3 times 0 is 3. 3 times 0 is what? 0. So 56 plus 36 is 92 plus 0. You get 92. Let's also try to balance the upper part. The upper part is what? 235 plus 1, you get 236. So when you add this plus 95, these 3 must multiply 1. So 3 times 1 is 3, plus 95 is 98. Then when you add it, the 98 to 135, you still end up with what? 236. So our equation is what? Balanced. So this is an equation which represents nuclear fission. Now, there was a question I asked. Where does fission occur? Where does fission, nuclear fission, take place? We said nuclear fission takes place in unstable atoms. Now, which example in this question, which one is the unstable atom here? It is uranium. So when somebody says, name where, okay, give us maybe one example where nuclear fission occurs, you simply say nuclear fission takes place in unstable atoms. And you give the example. Don't end up saying unstable atoms. The examiner will be interested in knowing that example. So you simply say it occurs in unstable atoms like uranium. And lastly, let's look at the conditions for nuclear fission to take place. 1, there should be an unstable atom, because it is that unstable atom which is going to split. So presence of a heavy unstable atom like uranium. The next thing you need is you need a neutron. You see, when you look at this equation, uranium must be there, the unstable atom, the neutron must be there. So that is our second point, presence of a neutron. What is the work of a neutron? The neutron is the one that starts the reaction, because the neutron hits the uranium atom, and then the uranium atom what? Splits. Now, the uranium atom will not split unless the neutron hits it. So you need the neutron, presence of a neutron to start a chain what? Reaction. And lastly, you need very low temperatures. Nuclear fission does not take place like nuclear fusion. With nuclear fusion, you need high temperatures. But nuclear fission, you need very low temperatures. So these are the conditions for nuclear fusion to take place.